We will continue solving other problems. But before that, I'm going to define one more thing to you. Yeah, in here we have one force, gravitational force, torque, only because of gravitational force is asked. But sometimes, but in several problems, you will see that there are more than one forces. And if more than one force acts on object, every force can produce a torque. So you should first calculate the torque of individual forces. So if more than one force acts on an object, you need to calculate net torque. It's similar in the dynamics last year. If there are more than one force acts on object, you calculated net force, resultant force. It's going to be in the same way. If more than one force acts on object, each force produces a torque. You should calculate the net torque in here. But first, you should calculate the individual torque of each force. After that, calculate the net torque by adding up individual torques. You will add them. So net torque is going to be torque 1 plus torque of the first force, plus torque of the second force, plus torque of the third force, plus torque of the fourth. How many forces acting on it? You will calculate the torques, and you are going to find the net torque acting on this object. And there's one question about this. This question is also a ministry exam question. Question number 2. If each force is 6 Newton, there are two forces acting on a wheel, and the angle between F1 and F2 is 60 degrees. Yeah, and this angle is given. This angle is 60 degrees. And the radius of the wheel is 1 meter. So this wheel has a radius R is equal to 1 meter. So what is the resultant torque on the wheel? So we will find the resultant torque or net torque, resultant torque. So torque net is the question. Rule: calculate individual torque. And there are two forces acting on the wheel. So calculate the torque for each force. Torque of F1. Question says each force is 6 Newton in magnitude. Yani this force is equal to 6 Newton. That force is also 6 Newton. Okay, let's calculate the torque for the first one, F1. Equation for calculating the torque is, we know, torque is equal to F d sine theta. For the first one, torque 1, I am going to say that torque 1. Okay, so first determine the direction of rotation. F1 causes a clockwise rotation or counterclockwise rotation about this axis of rotation. It is counterclockwise. Show it like this with arrow. Counterclockwise rotation. This force causes counterclockwise rotation, so it must be positive. So then let's find it. Torque 1 is positive. F is how much? 6 Newton. What is distance from where force applied to the axis of rotation? Is the radius of the circle, radius of the tire, which is 1 meter. So that is distance, and it is equal to radius 1 meters. So 1 multiplied by 1. An angle between the distance and the force, 90 degree. Tangent line always perpendicular to radius, sine 90. So torque of the first force will be, because it is 1, positive 6 Newton meter. Torque of this force is positive 6 Newton meter. Now let's go with the second one. But second one is making an angle with F1. I mean, this angle is 60 degree given. And this force causes clockwise rotation and counterclockwise rotation according to that point. What do you think?
Counterclockwise?
Yeah, again, counterclockwise. I'm going to show you a way how to find it from after this There's a simple way you can use your pen to get the direction of rotation. It's counterclockwise again. Positive. Torque 2 is positive. How much is the force? 6 Newton. How much is the distance from force to axis of rotation? What is that distance? Again, 1. What is angle between the force line and distance line? What is angle?
60.
Aman Allah, don't write 60 because it is not the angle between
30.
force line and it is this angle you need.
Yeah, so it's 30, right?
It is 30, yes. 90 minus 60, which is 30. You are going to get always the angle between the force line and distance line. So this is the angle what you are going to put in equation. Sine 30. Sine 60 is given in the question, but it is not the angle between force and distance. It is the angle between force and perpendicular line. It's not the angle what we need. We need the angle between the force line and distance line, which is 30 degrees, sine 30. So when you multiply them all, you will get positive 3 Newton meter is the torque of second force, torque 2. Is there another force acting on the wheel? No. So calculate the net torque. Torque net is equal to torque 1 plus torque 2. Positive 6 plus 3, which is equal to 9 Newton meter is the magnitude of the torque acting on this wheel. I'm going to show you how to find the direction of the torque, positive or negative, now by sharing my camera. Okay, so let me stop screen sharing, and then I will open my camera. So this is the disk. So this is axis of rotation, center. You want to find the forces acting like this. So force is pushing the disk like that. You see it? So then you are going to push the object in the direction of the force and see that rotation is in which direction. So it is in counterclockwise. If you push it from that point, it's counterclockwise. But of course, you are not going to have a disk in the exam, but you will have a pen instead of this in the exam. And you are going to fix it from the axis of rotation. This is axis of rotation. Fix your pen from axis of rotation. And push from where the force applied. This is the where force is applied. So in which direction my pen is turning now?
Counterclockwise.
That is what you have to do. Always take your pen, fix from axis of rotation with your finger. This is axis of rotation. And push in the direction of the force in the question. And then see that pen is rotating clockwise or counterclockwise. If it is clockwise, negative. If it's counterclockwise rotation, it's going to be positive. This is how we are going to get if rotation is clockwise or counterclockwise. I'm going to use this pen in coming problems, and you are going to see how we use it, okay? So now we go on with the next problem. Next problem is best for this question. I have to use this pen and then find the axis of rotation. It's a sample problem. Sample problem, page 97, malzeme. A basketball is being pushed by 2 players during tip-off. This is the shape of a basketball. This figure is given in the book, don't worry. All these are given this shape in the book. So according to this figure, we are going to answer the question. A basketball is being pushed by 2 players during tip-off. One player exerts a downward force of 11 Newton. So this is the downward force of 11 Newton. And the other at a distance of 7 centimeter from axis of rotation. That distance is given as 7 centimeter. This is the axis of rotation. So even if they converted 7 to 0.07 meters, is the when you divide 7 centimeter by 100, you convert it to meter, 0.07 meters from the axis of rotation. The second player applies an upward force of 15 Newton. Another player applies a 15 Newton force at a perpendicular distance of 14 centimeter from axis of rotation. That perpendicular distance is 14 centimeter, and it's given as 0.14 meters from the axis of rotation. At this point is the axis of rotation. We put O, right? O for axis of rotation. So that point is axis of rotation. And find the net torque acting on the ball. Find the net torque acting on the ball. This is the question. So there are two forces acting on the ball. So then you are going to calculate the torque of each force, and you are going to add them. Let's continue with the one on the right side. Let's calculate with this one. So it's the second force, F2. And I'm going to first find direction of rotation is clockwise or counterclockwise. I'm going to use again my pen for this. I will share the screen, say my desktop. I am going to fix the pen from where axis of rotation is. Axis of rotation is on the left. Then push it down in the direction of F2. When I push it in the direction of F2, can you see that rotation is in which direction?
Yeah, it is
clockwise. Clockwise, yeah. F2 causes a clockwise rotation. So that's why it's going to be negative. Clockwise is negative. What about F1? So fix it from the axis of rotation. This is axis of rotation. Right side is axis of rotation, right? On the right of the first is axis of rotation. Push the pen in the direction of F1. So what is the direction of rotation?
It's still clockwise.
Still clockwise, yes. There are both force, both F1 and F2 causes a clockwise rotation. So which means F1 produces a negative torque. F2 also produces a negative torque. Both of them produces negative torque in here. So then we got the direction. If we got the direction, now we are ready for calculating the magnitude. So let's start with the one F2, torque 2. Torque 2 is equal to F2 times D2 multiplied by, I don't need to write sine 90 because both angles are 90 degrees. Şimdi yazmayacağım artık. 90 degrees, sine 90 is 1. F2 times D2. So it is D2 is equal to, it is negative, yes, negative. Don't forget negative. F2 is how much? 11 Newton. How much is perpendicular distance from this 0.07? So multiply them all. 11 times 0.07, which becomes negative 0.77. Negative 0.77 Newton meter. This is the torque of the second force. Let's do for the first one, F1. So it's also negative. Torque 1 is negative. Yeah. How much is F1? 15. So let's write the equation first. Torque 1 is equal to F1 times D1 times. Again, angle is 90 degrees. For that reason, I'm not going to write this angle. Sine 90 is 1. So F1 times D1. F1 is 15. D1 is from force to the axis of rotation perpendicular distance in here is 0.14. Multiply them. So which is equal to negative 2.1. So we got them. We got torque 1 as negative 2.1. We got torque 2 as negative 0.77. Any more force acting on the ball? No, only 2. So then now I'm ready for finding the net torque. Net torque is equal to torque 1 plus torque 2. Torque 1 is negative 2.1 plus torque 2 is negative 0.77. And then positive negative becomes negative 2, negative 2.1, negative 0.77. When you do this by your calculator, answer is negative 2.87 Newton meter. The net torque acting on this basketball is negative 2.87 Newton meter. So because the net torque is negative, this basketball is rotating what?
Clockwise.
Yes. If the net torque is negative, so this object is rotating clockwise. Basketball is rotating clockwise. And sectional question. This is the maybe only 3 force we have in here. This sectional question. Calculate the torque for each force acting on the bar. It's a rod. Bar means rod in figure. Assume the axis is perpendicular to the page and passes through the point O. Axis of rotation is given in the question. This is the axis of rotation. In what direction will the object rotate? We are going to check net torque. If the net torque is positive, rotation is counterclockwise. If net torque is negative, rotation will be clockwise. We are going to check it. There are 3 forces, so then you should calculate 3 torques. So I will say this is the torque 1, the one on the left. I will start from the left. But this force, 30 Newton, acts on axis of rotation. If a force acts on axis of rotation, what is the torque produced by that force?
0.
Yes.
0.
Torque 1 is 0. I will say torque 1 for this one. This is 0. Because the force is acting on axis of rotation. It cannot cause a rotation. Let's go with this one. I will say this is this torque 2. This produces the second torque, 10 Newton force. So now let's get the direction of rotation first. Direction of the rotation is clockwise or counterclockwise. I will again use my pen. So this is the pen. The force is in here. The axis of rotation right here on the left side is the axis of rotation. On the right, there is the force. Push the pen in the direction of the force. Push the pen in the direction of the force. Rotation is
Clockwise.
Clockwise. It's clockwise if you push it like this. That's why this force produces a clockwise rotation, so negative. Torque 2 must be negative. So I'm going to now write equation for torque 2. Torque 2 is negative. How much is the force? 10 Newton. What is distance from force to axis of rotation? From force to axis of rotation. How much is the distance?
4.
Yes. Where is axis of rotation? O is axis of rotation. Where is the force? In here. What is distance between these 2 points? 4 meters. Distance is 4. Multiplied by sine of angle. How much is the angle between the force line and distance line? How much is this angle? Everything is given very nice. 23. I got everything. Just multiply them and find torque 2. Torque 2 is equal to negative. So when I multiply them, answer is going to be, I think, let me check from my notes, negative 15.6. Negative 15.6 Newton meter. This is the torque of the second force, torque of the first force, torque of the second, and go with 25 Newton. Torque 3. Torque 3. So direction. First, I have to get the direction. Rotation is clockwise or counterclockwise. Again, I will share my screen. You see, this is the axis of rotation, left side. Push from the middle in the direction of the 25 Newton. I am pushing in the direction of the 25 Newton. Rotation is?
Counterclockwise.
Counterclockwise. Yes, my pen is rotating counterclockwise. This is axis of rotation. Somewhere in the middle is the force. I am pushing my pen in the direction of the force, and then my pen starting to rotate counterclockwise. So 25 causes a counterclockwise rotation, which is positive. So torque 3 must be positive. So let's calculate torque 3. Torque 3, which is positive. How much is the force? 25. Distance. Where 25 Newton is acting? In here. So from here to axis of rotation, what is that distance?
2 meters.
Yeah. Students are making mistake in here. They are taking the whole length of the bar. It's not whole length. From force to axis of rotation is 2 meters. And last point. Angle between the force and distance line. Is it 31?
I think so.
Are you think? No, don't think so. Distance line is
scared. I don't know if it's true or not.
Careful. This is the distance line. This is the force line. Angle between them is here, in here.
But teacher, the distance doesn't extend to the other part.
Extend distance as much as possible to get the angle, okay? This is the 25 Newton acting like this. Question is giving you the angle, this angle as 31. Ama bizim angle distance'ımız şurası. This is distance. Always draw a line along the distance as long as possible. Draw a line along the force as long as possible. And then find the angle between these two. Which is equal to 90 minus 31, which is 59 degrees. 59 degrees is the angle. So this angle is 59 degrees. So sine of 59 degrees. So then positive, if you multiply it, you will get the result as positive, I think, 42.8 Newton meter. Positive 42.8 Newton meter torque 3. So we got 3 torques. We got them all. Now we are going to calculate the net torque. Net torque is equal to torque 1 plus torque 2 plus torque 3. So torque net. Torque 1 is how much? 0. Torque 2 is how much? Negative 15.6. Torque 3 is how much? Positive 42.8. Use your calculator and get the net torque. Net torque is positive number. Positive, I think 27.3. 27.3 Newton meter. Because it is positive, rotation is counterclockwise. So this bar rotates in counterclockwise direction.